Hello friends, today we are going to start with 8th unit of our syllabus titled as Atom and Nucleus. This unit has two chapters, chapter 12 and chapter 13. Chapter 12 deals with atom and chapter 13 deals with nucleus. First we take up chapter 12, that is atom. Now how we are planning to learn this chapter, the mind map is shown here. First we will take up atomic models. At the second stage we will take up Bohr's atomic model, and in the third stage we will take up energy level diagram of an atom. In the fourth stage we will take up size of nucleus, and in the fifth stage we will take up liquid drop model of nucleus, and in the sixth stage we will take up discovery of isotopes and neutrons. So step by step we will take up topics. Now first topic we take up as atomic models. The 19th century picture. I take you back to 19th century picture of an atom. What is that? Towards the end of 19th century, what was known about an atom is given as under. First, atom is an invisible smallest particle of matter. Second, atom is electrically neutral. Third, number of electrons is equal to number of protons in an atom. Fourth, electrons are negatively charged particles and protons are positively charged particles, and both possess same magnitude of charge. The burning question had been as to how these charges are distributed in an atom. During course of time, various models were proposed. I repeat, burning question at that time had been as to how these charges are distributed in an atom. During course of time, various models were proposed as an answer to this question. First, J.J. Thomson model of an atom. Watermelon-like model of an atom was proposed by him. According to him, atom is basically a spherical cloud of positive charges with negative electrons embedded into it like seeds in watermelon. I repeat, atom is basically a spherical cloud of positive charges with negative electrons embedded into it like seeds in watermelon. Now see here in the diagram, red part shows the positive charges in the watermelon and black spheres, black small spheres show electrons embedded into it like seeds in watermelon. Now difficulties with Thomson model of an atom. First difficulty had been the locations of electrons were not known. And second, the model was unstable because slight perturbations were expected to cause oscillations of electrons about their mean positions, such that light of particular frequency could be radiated. I repeat, first difficulty had been about the locations, that is, locations of electrons were not known. And the second difficulty had been about its stability. The model was unstable because slight perturbations were expected to cause oscillations of electrons about their mean positions, such that light of particular frequency could be radiated. In order to overcome difficulties with J.J. Thomson model, Rutherford proceeded to conduct an experiment and proposed planetary model of an atom. And now we talk of Rutherford's planetary model. Now, planetary model of an atom was proposed by him on the basis of famous alpha particle scattering experiment. Let us first understand alpha particle scattering experiment. Experimental setup. High energy alpha particles emitted from a radioactive element were utilized for bombarding a thin metal foil. After bombardment, the following observations were made. Now, in experimental setup, you see in diagram there is a thin metal foil and a beam of high energy alpha particles emitted from radioactive element which were used to bombard this metal foil. Now, observations of the experiment. First, most of the alpha particles traveled undeviated, like here you can see. Second, some suffered large changes in their direction, like this and this. Third, some retraced back their path, like this particle. And when number of particles scattered n versus scattering angle theta graph was plotted, it came out to be as shown in diagram. Okay, so this is how observations were recorded and the graph was plotted. Now we come across a term, impact parameter. What is impact parameter? We are to define it. Perpendicular distance between the particles undergoing 180-degree deviation to the particles going undeviated is defined as impact parameter. It is denoted by the letter B and is given by the Rutherford scattering formula as B equal to ZE square cot theta by 2 divided by 1 by 4 pi epsilon 0 into kinetic energy of alpha particles. This is how this expression for impact parameter was derived on the basis of the observations made. And when number of particles scattered versus cot theta by 2 graph was plotted, it came out to be a straight line. Okay, here you can see the impact parameter is from this particle going straight to the particle undergoing 180-degree deviation. So between the perpendicular distance between these two lines is called as impact parameter, and theta is scattering angle. Okay. Now inference is drawn. What were the inferences drawn after doing the experiment that we are to see now? This deflection of alpha particles may be due to two reasons. First, repulsion by the positive charge on the atom and attraction by negatively charged electrons. I repeat, this deflection of alpha particles may be due to two reasons. First, repulsion by the positive charge on an atom, and second, attraction by negatively charged electrons. Now let us take up point by point. First point, the positive charge in Thomson atom is spread too thin to exert a strong repulsive force for large deflection. What? He argued that the positive charge in Thomson atom is spread too thin to exert a strong repulsive force for large deflection. Therefore, charge is not spread over whole of the atom but is concentrated at one point in the center of atom called as nucleus. So what was the conclusion made? I repeat, the positive charge in Thomson atom is spread too thin to exert a strong repulsive force for large deflection. Therefore, he concluded that their charge is not spread over whole of the atom as in Thomson model, but is concentrated at one part in the center of the atom, which he called it as nucleus. Second, because deflection of alpha particles is due to two forces, first, repulsion by positive charge and attraction by negatively charged electrons. Therefore, it can be assumed that the negatively charged electrons are revolving around the nucleus like planets around the sun. I repeat, because deflection of alpha particles is due to two forces, first, repulsion by positive charge, second, attraction by negatively charged electrons. Therefore, it can be assumed that the negatively charged electrons are revolving around the nucleus like planets around the sun. Okay. Now, third, force of repulsion F is given by Coulomb's law, which can be expressed as F is equal to K naught 2E into ZE divided by R square, where R is the distance of closest approach to the nucleus. Here you can see the particle, central particle, which is undergoing 180-degree deflection, that can reach the nucleus to a closest approach. After that, it is repelled and it retraces back its path. So here you can see in the diagram, this is the distance of closest approach. Here you can see that this is the distance of closest approach, R. Okay. Now, difficulties with Rutherford's model. Main difficulty with Rutherford's model of an atom had been its stability. Rutherford's atom was not stable, though it described locations of positive and negative charges, which were not known in Thomson model. Now, what he said about stability. If we consider electrons to be at rest, they will be attracted by positively charged nucleus and ultimately they fall into nucleus. Second, if they described closed orbits, electrons will radiate out energy and spirally fall into the nucleus and the system will run down. I repeat, first, if we consider electrons to be at rest, they will be attracted by positively charged nucleus and ultimately they fall into the nucleus. If they described closed orbits, electrons will radiate out energy and spirally fall into the nucleus and the system will run down. So, Rutherford model was also suffering from stability consideration. It was also unstable. Now, the difficulties of Rutherford's model were overcome by Bohr's model of an atom. Now, how these difficulties were overcome, we will take up in the next lecture. Now, assignment 12. Question number 1. What had been difficulties with J.J. Thomson model of an atom? Question number 2. How Rutherford overcame the difficulties of Thomson's model of atom through alpha particle scattering experiment. Question number 3. Define impact parameter and give its expression. Thank you so much. Next time we will take up Bohr's atomic model, whereby we will see that how unstable Rutherford's model of atom was made stable. Okay. Till then, goodbye and good luck.